Hey guys, welcome back to the stream. I think it's going to be a pretty quick stream today. I need to turn off the audio here, or at least turn it down. Yeah, had a little bit of work yesterday, made a little bit of progress, but also hit a bit of a roadblock. So I wanted to show you some funny gifs of crazy planet blowing up stuff. Show you a little bit about something I don't think I've shown on the stream before that I actually did a little while ago. Give you a quick little look into some of the things that I'm simulating sort of under the hood. Also, next week for about 2 weeks I'm doing a little family road trip, so I probably won't be able to stream during that time. So there'll be a little break and then I'll come back around the beginning of October, maybe late September. And then we can look at a little bit about maybe at the thing that's currently frustrating me. These gifts here. So I think you probably saw the one on Facebook of the exploding planet, but I'm having some weird stuff where I get what's called not a numbers in some of this simulation values, and then it just causes the planet to basically get to explode and look really hot. And so that's one example that looks pretty cool. Sometimes the things that mess up look cooler than the things that work correctly. And then here's another one, just sort of a different way of the planet blowing up. And we'll take another look at that a little later. So, one thing I added, let me draw some land here. So yesterday you saw probably that, like, if I drew any land on the planet, it would kind of do something like in the GIF there. And so now I can actually have a stable surface, but there's still some problems. But what I want to show you is, like, I added a thing where you can zoom in, and then once you zoom in to a certain level, it kind of tilts the camera, so it looks kind of like, you're on the surface of the planet. And so my thought is, eventually, once I get all the simulations working and everything, that you can actually get pretty close down in there and get a cool view of the planet's surface with actual trees and things once those start growing. So I think that'll be pretty cool. I need to adjust some of the depth of field stuff for that case, because as you can see, it gets kind of blurry when you get too close. Hopefully that'll be coming, maybe in a month or so. We'll see. And I wanted to show you. So, like, if you look at, so this was sort of a list I drew up early on about, like, different things I wanted to, like, have basically values for. So for, like, the air, you have temperature, you have the speed, you have how much water, oxygen, nitrogen. And I'm calling it CO2. Like you see up here, I was saying CO2/methane. I'm just thinking of it as, like, basically a greenhouse gas, but it also can affect plant life. And particulate mass is for stuff like smoke and all that, and which actually have all these values. So it's quite a lot. And then land, you have, like, its elevation, temperature, is there any vegetation, how much water, and you can see stuff starting to get a little funky actually on the planet as I let it run. You can see the sort of hex pattern of the vertices pop up because the simulation's going a little haywire. But you have like a color of the land, which actually at first I was doing just like a color, but now it's sort of indices into like a color palette. I have this value for ice kind of there, but right now I'm just using it for debugging, because if there's any ice that shows up, it's sort of not something that's stored, but just as a function of the temperature, and then the sort of the direction the surface is pointing. And so those are kind of the values you have, and some things like I wanted to be able to kind of represent as phenomena, temperature, humidity, winds, clouds, rain, ocean currents. So all these so far actually have, to one degree or another. It needs some improvement. Eventually I want to be able to get hurricanes to just sort of spontaneously form. I think that'll be super cool. these other things are all there. Sun heating is actually something I've been working on, as well as the emission of heat back out into space in the form of infrared. Adiabatic cooling is a crazy fancy word for something that we all kind of know intuitively, which is like when you go at a higher elevation, things get colder, the air expands and it cools because there's less pressure, because there's less air above it. Snow and ice. Sea level rise due to land ice melt. Theoretically, I should be able to simulate that, except I don't usually get that much land ice, and I don't know how visible. Like, the tricky thing is like something that's significant for human civilization. Say, imagine if the seas rose like 50 feet. That would be pretty dramatic, but that would be like hardly visible in the like the actual visual size of the planet. We'd have to have a lot of like low-lying landmass to actually make that visible. One thing I was thinking about, so right now I basically have a 1-layer atmosphere model. I do some hacks to try to simulate things like the jet stream, but essentially it's 1 layer, but it'd be interesting to have like a multi-layer simulation. And then all this stuff. So there's a lot that actually goes into it. In fact, if we look at some of the code here, you can see I basically have all these values. There's 4 plus that's 16, 18 different kind of simulation values, plus I have kind of things that don't really change, which are like the position of the vertex and its like direction. Yeah, that is that stuff. So yeah, I guess it's time to look at this. So as I was saying, there's some stuff that's definitely not right. I believe this is actually due to wind, believe it or not, that's causing this weird pattern. Or if you look at this surface temperature, it's kind of, if I pause the simulation here so we can kind of inspect it, you know, and here 263, 264, 285, so like the freezing point of, or melting point, depending on how you look at it, is of water is about 270 degrees Kelvin. So things are just kind of crossing over that threshold in weird ways. And also I noticed for some reason, I can't quite understand this, is the mouse over data that I have, like you can see in the upper left corner of the window there, where it says surface temperature. So it seems somehow to be off a little bit. I don't quite understand it yet, because I'm mousing over the area that's ice, so it should be less than 263, but it's not. And then this area is definitely above, but it just, I mean, did I say 263, 273? So like this area is above 273, but it's telling me 269, 268. So something's up with my raycast or something to give me the wrong value. So at some point I need to look in that, but it's kind of good enough for now, like in the rough vicinity. And the way I'm doing my raycast actually is I take the entire mesh, which is like at this point I think it's 40,000 vertices with I think even more triangles, and I send all those to the GPU, and then dang it, stupid spam. I'm getting a lot of spam phone calls lately, and I just trace that ray through every single triangle, and since the GPU can just burn through data, it can do that no problem. So I could have like 10 raycasts per frame, say, and 100,000 triangles, and that's like 1,000,000 ray triangle intersections, and it's actually not too bad for the GPU. That'd be terrible on the CPU. But on the GPU, it's at some point I might need to optimize it, but right now it's really not necessary. And then anything that actually intersects, I send that back to the CPU, and it sorts through them and picks the first intersection. So the problem I'm running into, and that I guess you could say I half fixed it, I was hoping it would fix it, was so in this phase, the diffusion, which handles wind as well as the flow of water. So it handles. Oh, my simulation's paused. Like when the land rises up, the water kind of flows out, and kind of you can push the water around. And so that's anything that has to do with cells or vertices affecting their neighbors. That happens there. Like the other stuff is all just kind of contained within one little cell. And I noticed with the wind, I hadn't updated the heat functions properly like I had done the other, but now I think I'm doing this correctly. So I compute for the water that's flowing in or out. Wait, this is water. So you can see what I did for water, because initially the water was doing crazy stuff too. I compute what's called the heat inertia, which is sort of like the heat capacity, if you will, like the amount of energy that a given amount of the mass can absorb, and then without changing its temperature too much, and times the amount of mass, and that gives you this concept of inertia. We can look at what that is actually doing there. Is basically for water, it's pretty easy. You take the specific heat of water, which is how much heat it takes to raise 1 gram, 1 degree Celsius or Kelvin, and then you just multiply that by the mass, and that's what I'm calling the heat inertia. And then if you're doing the whole land, it's a little bit more complicated, just because you have some water and you have some solid land, and then the air is basically I have your oxygen and carbon dioxide and whatever. I'm just saying they have a specific heat of 1, and then I also can look at how much water is in the air and kind of compute a mix of that. And that's kind of how it works. Instead of before, I was just doing straight mass times temperature, and I wasn't considering specific heat at all. And when you update it in one place to do this, you have to make sure you update it everywhere. And I found a place where I was missing it. For example, air pressure and wind, and in the jet stream. But now I updated basically these lines here. To properly compute the amount of heat energy that's transferred when you move air from one cell to another. And then again down here, so I have kind of 2 parts. I have what I call the jet stream, which right now is a little bit fake, and the basic idea is that hot air will be less dense, and it'll sort of make a taller air column. And what that means is high up in the atmosphere, even if it's lower pressure at the ground, when you get high up, say in the jet stream, it'll be higher pressure than the neighboring cold area, so it'll create winds that flow actually from the warmer area to the colder area. In that case, they can get quite fast. The jet stream can be on Earth can be hundreds of miles per hour. So that's why you get that crazy turbulence on an airplane, and people go, "Oh my god!" Yeah, so do that, and that basically moves. Right now, I don't have any sense of momentum to that, so I don't get a real jet stream sort of going around the planet. But it moves mass from one section to another, so I can get pressure differences at the bottom, and then that generates surface level winds, which come in over here. And again, it looks like I fixed up the calculation of the heat there and here. I wonder if this adiabatic stuff is somehow messing with it. So now I'm curious if I just take the neighbor's air temperature. Shouldn't really be such a crazy problem, but especially since most cells are at the same at 0 elevation, so it shouldn't really affect the temperature. But I'm gonna go ahead and restart the simulation just to see. And so I did that, and then there's the other part below where I actually use that out air heat to affect the final temperature. Where does that happen? Or am I... That could be a problem if I'm not even using that value. Oh, maybe So at some point I had... I guess I commented it out because I thought it wasn't working right. But you can basically see, like, this is the initial amount. Let me uncomment this. I have this initial amount of heat minus the change, and then sort of divided by the final amount of inertia. So what this means is, like, basically, if, say no air came into a particular cell, air only went out, this should end up with the same exact temperature, because this final heat inertia should change in a way that exactly counteracts subtracting out the heat for the air that left, and it should be the same. And I can see I'm already getting the weird hex cells at the top here. Wait, let me re-enable that code there and see what happens. And this right here that I've kind of commented out is like I was trying to basically, so I stored my velocities, like wind and stuff, in what I call local polar coordinates, which are basically like how much is it along the latitude and how much is it along the longitude. And initially I was kind of decompressing that into a full 3D vector, doing the math on that, and then recompressing at the end. Except at one point I was forgetting to recompress, and it was causing problems. So I just said, you know, I'm just going to do everything in that polar coordinate space. So I don't need to do any of this decompress, recompress stuff, but I'm still getting some craziness. And the thing is, you can see that if I let's go ahead and turn off all the like interactions between neighboring cells. And this is stuff that used to work before I started changing the units and heating equations. So if I disable that, well, you won't see the land, the water flow up the land, so the water will be really high. It'll just be a water mountain. But everything should kind of be relatively smooth. You know, if we look at, for example, surface temperature, starting to see, you know, in the south, since it looks like the sun's in the north hemisphere, the south pole is getting kind of cooler. Air temperature, you know, it's pretty smooth. You can see here where I have like lines of equal temperature. You know, they have a nice. It's just a smooth pattern. There's no weird stuff. There's no like going back and forth. So I could let that run all day, I'm fairly certain, and everything would be peachy keen. But so I don't. It's really annoying to try to figure this one out. So yesterday I was working on this, and I was just I think my brain just got tired, so I took a little break and played some games, and then I started working on something totally different. Just sometimes you need to do that, and you get stuck on something. You need to work on something else for a while. So that's why I don't have that much progress from yesterday. So what's interesting is I was getting those weird patterns even though. So that's the air temperature. So if I disable that again, and then there's somewhere where I'm updating the surface temperature too. So if I disable both of those and then re-enable just kind of water and wind flow, I think things will be okay and you won't get those weird hex patterns. Where is the surf temp? Oh, it looks like I disabled already the surface temperature stuff too for testing purposes, and then all this stuff right here. Oh, even the stuff that I uncommented was actually in this block here that I had disabled everything. So that's weird. So now that's actually quite confusing. why things are going crazy. So where was that surface temperature again? So there's that commented out. So right now, I'm updating the amount of water in the air and the amount of smoke, but not the amount of gases. So what I could do is just, I was trying to figure out, like, okay, at what point does stuff start going crazy? So if I re-enable, okay, everything's re-enabled. So that's looking a little more, it's getting really cold for some, that shouldn't be so cold, but at least it's not that crazy hex pattern. And the sun melts it away, and so there's a lot about that that's working a lot better. And then if I go back and put it here again, what happens? I forgot that I had disabled so much of this in the testing process. And it's starting to get weird. This planet likes to get weird. And if I go and look at different things, so I can update this. Oh, interesting. I need to make it where it doesn't do anything to the planet when I click the buttons. Whoop. Yeah, look at the different visualizations, which also affects, the mouse over data in the corner there. But sometimes I like to look at it, say normally, but still have that mouse over data change. So I can just come here and manually tweak something in the Unity UI. Where am I looking? Yeah. So if I look at, let's look at the air temperature. Is it going? So the air temperature looks pretty smooth as I move across these regions. And what about the surface temperature? Oh, huh. Yeah, there's a sudden. And right now the mouse over is interpolating between the different vertices of a triangle. It'd be interesting to see if I just sort of pick the nearest and if I can see sudden jumps more easily. But it seems right here it dips pretty quickly for some reason. And I'm not even sure what would be affecting that, because it's if you look at what I changed, it's actually only air stuff that's changing. But somehow that's indirectly affecting the surface temperature. I'm affecting, for example, the amount of water, which could affect the rate of evaporation from the surface. So if I were to look at surface relative humidity, maybe there's some clue there, which is really crazy high. Should be about 1.0 should be the highest it goes, but it's really high for some reason. Unless I forgot to update. I think I updated the calculation for that, and because I have a calculation for that in my compute shader that does the simulation, and then I have a calculation for that in my a rendering shader for the clouds, and also on the CPU when I look at this data. So I can look at look for that. Let's see. Does this look? This looks like the right calculation. So we have a place where it's about 20 degrees Celsius, about 1.4 kilograms of water in the air. Is that a lot? I'm not sure. And so the relative humidity, is 58, because the vapor pressure is pretty low at that temperature. So this is based on something called the simplified Antoine formula to compute. So vapor pressure is basically like you have water vapor in the air and basically a gas form. And how much pressure would that put, like sort of partial pressure, relative to all the other gases in the air, put on things around it? And so you have like liquid water at the surface of the ocean has upward pressure, and then the water in the air has pressure, and they're pushing back on each other, and whichever one is greater is sort of gonna win, and that determines if you have evaporation or condensation. So I don't exactly know why I have so much water in the air, except I mean in the compute, so there might be some problem with how much water I'm computing is going in or out. And yeah, so that probably has something to do with it, like it's not conserving. In fact, I think I have a thing that's I can look at that's like total water. So it's crazy. Like every little thing has to be right, or the whole simulation can just go bonkers. And so like conserving values across across the whole planet is really important. Otherwise, like you have just magical water appearing from nowhere or disappearing. I've had times where the whole planet was gaining water so fast it just kept expanding until it just exploded in a giant water supernova. Total water mass. Yeah, let's look at that. So that's, yeah, everywhere is, I think 300,000 was the starting amount of water in the ocean, and you start off with no water in the air, and like everywhere it seems to be have gained water, except for obviously the dry land. Like all over the planet, I don't see anything under 300,000, just above. So that's a little hint right there that something's, oh, except in some of the icy places, I guess. There are a few spots that are really low. Like that does, oh, it's like an indentation, look at that. So I don't know what that's all about. So that is my clue. So I'm going to spend some time trying to figure that out. So now you know where I am, what I'm dealing with. And hopefully next time I'll have a solution to this. It looks like there's something going wrong with the conservation of water mass. So with that, it's going to be a little while. And I will see you next time, probably in about 2 weeks. Alright, I hope this was entertaining for you and interesting and as good as a peanut butter and jelly sandwich, which apparently British people don't eat, which is a damn shame. I was at PAX and I was talking to a British guy, and I was just saying like how good PB&J is, and he just sort of stared at me blankly. And I was like, have you ever had PB&J? And he just said, no, I don't think I have. And that just blew me away because it's so easy and delicious. But anyway, see you next time.